Hey guys, this is from Savvas 8th grade basic math, lesson 1-7. In this lesson, they are talking about some more properties that deal with integer exponents. So first, let's remember what integers are. Integers are, they continue forever. -3, -2, -1, 0, 1, 2, 3, ... which means they go on and on. Also, let's remember what an exponent is. An exponent, in this example, 2 to the 3rd power, is this small 3 right here. That's your exponent. The 2 would be considered the base. So in the number 2 to the 3rd power, 2 would be considered your base, and 3 is your exponent. Those are just some reminders to help us with this lesson. One property they are discussing in lesson 1-7 is called the zero exponent property. The zero exponent property tells us that a to the 0 power is equal to 1. Remember, a cannot equal 0. But the zero exponent property is teaching us that a to the 0 power is always going to equal 1. Now remember that a is just a variable that represents any integer, except for a cannot equal 0. So, this zero exponent property is really pretty easy. It will be your favorite one because it's so easy. It just says that any number raised to the power of 0 will always equal 1. Anything to the 0 power will equal 1. So some examples are 3 to the 0 power equals 1, 1,000 to the 0 power equals 1, -7 to the 0 power equals 1, 43 to the 0 power equals 1, 0.5 to the 0 power equals 1, 1 million to the 0 power equals 1. Easy enough. The zero exponent property means anything raised to the 0 power will equal 1. That will be your favorite one. The next thing that lesson 1-7 talks about is another property called the negative exponent property. Now, the negative exponent property says that, and this is in your textbook, a to the negative nth power is equal to 1 over a to the positive nth power. Now again, a cannot equal 0. Now this looks a little complicated, but we'll work through it. So a, again, just represents an integer, just not 0. And n is your exponent, and it also will represent an integer, just not 0. So let's look at the example. If you have 3 to the -2nd power, the first thing you want to notice is this is a negative exponent. So you have a base of 3, but it has a negative exponent beside of it. So when you see that, that's when you're going to use the negative exponent property. This property right here. So when you see that, what you need to do, and your book doesn't show it this way, but it might help you to visualize it, to see it this way, at least in the beginning. So what I would like to do is say, come up here to what your book has, a to the negative nth power, and let's put that a right there, over 1, okay? So in this problem down here, a equals 3, and n, which is our exponent, see how n is our exponent? N in this problem is 2. But don't forget, we have a negative exponent, Okay, so the first thing you need to recognize when you're doing your math problems is, oh, look at this, I see a negative exponent, so I need to use my negative exponent property. And so what we would do to solve this problem, 3 to the negative second power, is, think of it this way. Remember how I said I like to put a line here with a 1? So this 3 is your base, which is a. Let's just remember, even though you can't see it, and you don't really need to see it at this age, but let's just remember that this 3 is over 1. So what I'm saying here is that 3 over 1 equals 3. So this 3 is over this invisible 1. To do the negative exponent property, you're going to take the reciprocal of your base. Your base is this 3 right here. This 3 over 1 is your base. So what is the reciprocal of 3 over 1? Well, to get the reciprocal of 3 over 1, you just flip it. So you say 1 over 3. That's your reciprocal. Now, the next thing you need to do with the negative exponent property is, remember how over here you start with a over 1 to the negative n power? And you're going to change it. You're going to do the reciprocal of your base. A over 1, the reciprocal of a over 1 is 1 over a. Now you need to change your negative n to a positive n. So our negative n in this problem is our negative exponent. We have a negative 2. We're going to change that negative 2 to be a positive 2. Keep that negative 2 with the 3, which is where it was to start with. Keep that negative 2 with the 3. But when you change it, remember that negative has to become a positive. So then, if your teacher wants you to go further in solving this, you could say 1 over, what is 3 to the second power? Well, that's the same as 3 times 3. So 3 to the second power is 9. So your answer to this problem is 1/9. I hope that helps. The more you practice that, the more you'll understand it. It just comes with time of doing more and more problems. So that is the negative exponent property. And remember, if it helps you to visualize and remember to put your number over 1. Put your base over 1 if that helps you. That helps me in learning how to do this initially. Eventually, you won't even have to do that though. The next thing I want to talk to you about is some more examples of the property we just covered, the negative exponent property, okay? So what you need to do here is remember that you're going to have problems or expressions to solve now that will have negative exponents in them, what we just talked about. So you may have directions that say, write these expressions using positive exponents. So when you see that, I want you to recognize right now you have an expression that has a negative exponent. So you have 8 to the negative second power. There's your negative exponent. That should be your clue. Oh, I'm going to use the negative exponent property to solve this problem because I clearly see a negative exponent here. So what you can do, if it helps you, and it does help me in the beginning of learning this, is 8 is your base. I like to remember this 8 is the same as 8 over 1. It just helps me to think it through. So what is the reciprocal of your base? Remember, your base is 8, which is also the same as 8 over 1. What's the reciprocal of 8 over 1? Well, you flip the numerator and denominator. So your reciprocal of 8 over 1 is simply going to be 1 over 8. 1 over 8 is the reciprocal. But you still have to deal with this negative exponent. With the negative exponent property, you're going to change your negative exponent to a positive exponent. So you're going to change that negative 2 to a positive 2. And that's your answer. Okay? Now, depending on your teacher, they may want you to go a step further. I don't know if they do right now or not. But 1 over 8 to the second power is equal to 1 over 8 times 8, which is 64. Okay. The next example, again, we have a base and we want to recognize, oh, look at this, here's a negative exponent. So we have to use the negative exponent property. Now, I'm going to, even though it's not necessary for some of you, it helps me right now. I'm going to put this over a 1. So this is the same as 2 over 1 to the negative 4th power. What is the reciprocal of 2 over 1? Well, it's 1 over 2. Now we still have this negative 4th power to deal with. We need to change this negative 4 to a positive 4 on the exponent. And there's your answer. Unless your teacher wants you to go out further and use your calculator and take 2 to the 4th power. The next one is 3 to the negative 5th power. Again, I like to put it over a 1 to help me. So take the reciprocal of your base, which is 3, or 3 over 1. That, when you flip it, is 1. You put the denominator in the numerator spot, over 3. Now you've got to make this negative 5th power a positive 5th power. And that's how you do those. These next problems are a little bit trickier. You're going to write these expressions using positive exponents. So, this problem says, I'm going to write it again because it's not as clear. It's 1 over 5 to the negative 3rd power. So, what you need to do is think about your numerator and denominator separately for just a minute. Okay, so you have 1 at the top. We're just going to leave that alone. 1 over, and then if we look right here, I see in the denominator, I see a base of 5 to a negative exponent. The base is 5 to the negative 3rd power. So that, again, is my clue. I'm going to use the negative exponent power property. How do I change 5 to the negative 3rd? Well, again, if it helps you, think of that 5 as being 5 over 1 to the negative 3rd power. So what is the reciprocal of this base 5 over 1? We'll flip it to be 1 over 5. And then you have to change that negative 3 to a positive 3. And now, there's one additional thing you have to think about here. And I hope that I'm doing this the way your teacher is doing it. So what I see here is a fraction. This right here is a fraction. Even though there's a little exponent in here, it's still a fraction. So when you have a base to a negative exponent, that's going to be a fraction. It changes into a fraction once you do the property rule. So now you have 1 divided by this fraction. And in years past, you learned that when you are dividing and you have fractions, you can do this keep, change, flip rule. So what you do with keep, change, flip is you say, keep the 1 in the numerator. That's what you keep. So you keep 1. You're going to change your sign, your operation. Right now we're doing division. This is our division. We're going to change division. What's the inverse or the opposite? Multiplication. So it becomes 1 times. And then we're going to flip the denominator. Right now the denominator is 1 over 5 to the 3rd power. We need to flip it. So now it's going to be 5 to the 3rd power over 1. And that's what we're left with. So when you solve this, you can, if you need to do this, most of you probably don't, you can say 1 is equal to 1 over 1. So 1 times 5 to the 3rd power is 5 to the 3rd power. 1 times 1 is 1. Well, obviously, to simplify that, 5 to the 3rd power divided by 1 is simply 5 to the 3rd power. So that's your final answer, 5 to the 3rd power. I'm going to stop there because the video is getting a little long. The other one is exactly the same. You do it exactly the same way. So that gives you some examples that will help you with your homework. Good luck.